A broken wire left this family with a broken pool heater. Mikey Pipes to the rescue!
We have a Hayward Summit XL pool heater. Let's get set up, fire up, see what's doing. All right, let's turn power on. We have condenser fan motor pops on. That's the first order of operation. dPc, Defrost thermistor error. All right, let's pop out these screws, which I absolutely hate. Plastic into plastic, like it really makes no sense. There are 5 screws, 2 on both sides, upper and lower, and then 1 in the middle. And then the bottom pulls out, drop it down. We'll put that off to the side. Where is the rating sticker? Sticker's gone, huh? Yep, you see? Maybe it's inside front cover. Let's take a look here. Ooh, what's going on in there? A lot of I don't know. Just checking just doing a visual inspection. All right, nothing out of the ordinary. All right. And it reset. Interesting how that error message went away and now it's rebooting. So I'm leaning towards a logic issue or a control board issue. Well, let's briefly talk about what dPc and also could be SHC error message. And now it just turned on the display. If you have it basically it's an indication of a shorted water temperature sensor. Right now we're in high pressure, and that's because my door or the cover is open. Let's put the cover back on. So now we have that high pressure error. That means that the system sensed high pressure on the refrigerant side of things, not the water side, not the pool side, right? But let's quickly go back to that dPc error. That's an indication of a shorted water temperature sensor. Common causes as a shorted defrost sensor. We have checked for any of the wiring for any shorts, and then check the sensor for resistance against the actual temperature of the pool. So if the resistance reads like very low or 0, you're going to replace the sensor. If the sensor is reading the correct resistance for the temperature of the pool water, you're going to end up replacing the board. Right now I want this HP to go away. Back to pool. We'll go through a time delay for that compressor to start up, and let's see if the error comes back. So we have that dPc error, which is water temperature sensing issue, and HP. If HP comes back and our coil is clean and our fan weren't working, then we more than likely have a control board issue, and we'll have to order that board for them. All right, the compressor just kicked on, actively running. Let me grab a digital psychrometer to read the outlet temperature of this heat pump. See what our temperatures are on top. $59, $58. So right now we are actively heating the pool. Temperature sensing fault error, dPc, may have been a short. So now we're going to have to investigate that, because the only thing I did was take the cover off and we had that error message, and then it went away and then it came back. So we either need to check our wiring. We check our wiring, and then if all that checks out well, and we'll check out the resistance of the temperature sensor, you could have a logic issue. So that would be a control board, the main PCB. And right now it's cooling. It's heating. 58.2 degrees on our outlet temperature, 58.4.5. We are actively heating this pool. It's running. If I take the cover off, we're going to have that HP error, because now we're not having that heating exchange going on with that coil, right?
This is the resistance chart for Hayward Summit pool heat pumps. At 100 degrees Fahrenheit, the resistance should be 2.741 kiloohms. At 80 degrees, it rises to 4.3 and increases as temperature drops. Here are the defrost and water sensors.
You know what? I'm surprised I missed this. I say this time and time again. A good technician is observant of their surroundings. Take a look at that. I totally missed this before. See that? Look at that. Wow. We totally missed that. Crazy. I can't believe I missed that. See that black and red wire right here. Look. Check this out, folks. There it is. That's our error. It's been a problem once before. As you can see, everything's wire nutted here. So what I am going to do is we're going to eliminate this here, since the temperature sensor is right there. We're going to run this line. We're going to drill a hole in the bottom right here. We're going to clean out the electrical compartment. We'll drill a hole in the bottom. Actually, no, we have a hole right here. Sorry. Hole right there, and we're going to wire it right to there. We're going to eliminate that disaster that's going on here, and we'll be fine. All right, so let's take this out right there. Okay. This is that, which is going to there. Let's just undo those two screws on those terminal right there. Okay, so there's that wire there. Pull this out over there. Now, I don't have the breaker off, I just have the switch off here, so we're gonna be aware of our surroundings. And there it is, folks. Insane. Crazy. Okay. There those are. Now, it's a little short. I'm just gonna keeping it real here, right? So we're gonna leave a little note on this pool heater. I'm thinking about extending it, but I'd rather not extend this. That way I could just keep that communication without having any wire nuts or anything, kind of like how that one. I wasn't gonna wire nut it again. Come on, no. I'd rather not use a wire nut unless I really don't, unless I really have no choice. So let's get this in there like that, and they'll screw that in. All right, they are both secure. There's some kind of creature up here. Right? Had to be some kind of creature, and it was just nibbling on the wire. It's crazy. Let's turn the power back on. Let's get the door on, and we'll leave a little note here. All right, compressor is running. I am not a fan of checking refrigerant temperatures and pressures by hooking up my manifold to the service ports unless I suspect there's a problem. Every time you connect your gauges, whether it's probes or analog, digital, or hoses, anytime you connect your equipment to the system, you have the potential for something to go wrong. So unless I suspect there's a problem, listen, if I put my hand on top of there and it's just ambient temperature air and it's not cold like the way it should be, because right now we're extracting heat from the ambient outdoor air temperature, right? We're extracting that heat. The refrigerant is that medium. The compressor is making these things happen, and it's transferring that heat that's extracting from the temperature outside into your pool, which is why when you put your hand on top of the unit, right, it's cold, right? Look, it's 57 degrees, but it is 77 degrees here right now, right? Same principle when you're working on your air conditioning systems, right? When you approach an air conditioning unit and it's running and you have hot air coming out of the top of the unit, that is the heat being extracted from your house to outside, and that refrigerant is the medium. Here it's the same thing, it's just all in one box, right? So you're extracting the heat from the air, right, and dumping it into the pool, and the result is cooler air temperatures coming out of the top of the unit. right? Similar, if this condensing coil is if this evaporator coil is clogged, right, you're going to have high pressure. Same way if the fan motor is dead or the cover is off, like we had earlier during the beginning of the service call. So you got to be situational awareness, be aware of your surroundings, and know how things work. And like I said earlier, I'm shocked that I missed that. I wasn't paying close enough attention. You know, the wires for the temperature thermistor on that insulated refrigeration line. I missed that, but that caused the issue that we're having here. And fortunately for them, we were able to fix it.